All right, welcome to Lecture 4, Sections Chapter 1, Cluster 4. So we're looking at the basic operations, addition and subtraction. So we're going to practice thinking about positive and negative numbers in terms of money. So here's our first one. Sam had $100. Oh, he had $100 on a gift card to Ross. Too bad Ross is closed right now. When he went shopping, he bought a $50 pair of shoes. Write a symbolic representation of the story. Okay, so he had $100. And then he went shopping and he bought. So he used to have $100. And then what did he do with that money? In a sense, he gave it away. It was subtracted from what he had. So if he had $100 in his wallet, you could think about taking out the $50 for the pair of shoes. So we'd say minus 50. The amount he had and then the amount that he spent. So how much money is left on the gift card? Well, 100 minus 50 is going to be $50. All right, Keikoa owes the bank $100. He paid back $25. Write a symbolic representation of the story using negative numbers to indicate the money owed. Okay, so he owes $100, which means since we're talking about owing, that's going to be a negative amount. So a negative 100, he owes that much. And then he pays back $25. So that's not how much he owes, that's how much he's giving back. So giving is an adding term. So we're adding $25. And there is our symbolic representation of the story. He owed the bank $100 and he paid back $25. The question, how much money does Keikoa still owe the bank? Well, he owed the bank $100 and he just gave back $25, which means he owes $75. So he owes $75. Period. Okay, so remember when we're answering word problems, you want to answer in word form. So you're going to answer with a complete sentence and a period and your units, plus a capital first letter. So while shopping at Ala Moana, Kelly bought a $25 dress with her credit card, then an $11 plate lunch. Write a symbolic representation of the story using negative numbers to indicate the money owed. Well, she's using her credit card, so she doesn't actually technically own that money. So she owes the $25 with her dress. And then when she went out and spent $11 on her plate lunch, she owes another $11. So there's a symbolic representation. So how much money does Kelly still owe on the credit card? Well, the amount she owes are these two amounts combined, which is going to be negative 36. So the sentence is, Kelly owes $36. Because remember, owes is when we're talking about money owned. She owes $36. Let's perform the indicated operations. Okay, so we have 37 and 19, and it's negative 37 and negative 19. Well, that's very similar to the scenario we had up here. So in essence, what I kind of did was I added 25 and 11, but I remembered that they're negative numbers. So I'm going to kind of do the same thing here. I'm going to add the 37 and 19, but remember that they're actually negative numbers after I add them. So that's going to be 16, 3, 4, 5, 56. So this is going to be negative 56. Some students like to think of it on a number line, if you wanted to. If we had a number line, for example, here is 0, and here is negative 37, and we're going to go back 19 more cases because it's negative. And you could count back 19 spaces until you get to the number 56, negative 56. Okay, so different ways to look at it. You can look at it in terms of money. You can look at it in terms of the number line. I tend to use the example of money. All right, so here we go. We have negative 10 plus 7 plus 2. Well, if we think about it, you owe the bank $10 and you give them $7. How much do you owe the bank? $3. So that's going to be negative 3 plus 2. And then you owe the bank $3, but you pay the bank back $2. So now how much do you owe the bank? Negative $1. Okay, real quick, please fix this on your notes. That's supposed to be a parenthesis, not a space. All right, so now this is where things become a little interesting. See this double negative here? When you see a double negative like that, it is going to end up canceling your negative. This is saying I want the opposite of negative 13. Well, what's the opposite of negative 13? Well, it's going to be positive 13. So this, when the negative, the double negative simplified, is actually going to be negative 17 plus 13. Okay, so whenever you see that double negative, good to take note of that. It cancels. So now we have, you owe the bank $17 and you pay them back $13, which means you still just owe the bank $5. Oh, sorry, that should be $4. Negative 4. All right, so here we go. No dollars plus $16. Well, it's just going to be 16. Next one. Ooh, here's that double negative again. So let's focus first on the double negative and get rid of that. So negative and a negative is going to be a positive. Okay, because it's saying the opposite of negative 17. So that's going to be 0 plus 17, which is going to be 17. And there we go. And the last one, this one's kind of fun. So first things first, I always like to go through and get rid of any of those double negatives that I see. So I see this one here. So I'm going to get rid of that first, create a plus sign. Then I'll rewrite the problem. Negative 1 minus 1 plus negative 1 plus 1. All right, we're going to work from left to right. Remember with PEMDAS. So negative 1 minus 1. Well, you owed the bank $1, and then now you owe them another $1. So you owe the bank in total $2. And then we'll bring down the ones we haven't worked with. All right, let me erase that. So now let's look at this. Negative 2 plus negative 1. Well, you owe the bank $2 and you owe them another $1. So you're going to owe the bank $3. And then bring down that plus 1 that we haven't used yet. So now here we are. You owe the bank $3, but then you pay them back $1, which means you only owe the bank $2. Okay, so positive and negatives. I find it helpful to think of it in terms of money. Some students think it's helpful in terms of a number line. So finding ways that helps you to figure out how to work with them, as long as you can find a good way to work with them. All right, so now we're moving on to multiplication and division. All right, so here's just some things to note. A positive number, okay, a positive number times another positive number. What is that going to be? So positive times a positive is going to be a positive number. Okay, but if we look at a negative number times a negative number, what do we get? So a negative times a negative. Now this is where it's strange. A negative times a negative is going to be a positive number. But a positive number times a, and please change this in your notes, it's supposed to be a negative number. A positive number times a negative number. Okay, so positive times a negative is actually going to be a negative number. Okay. So a way some people like to remember this is if the two signs are the same, it's going to end up being a positive. So 2 positives is a positive, 2 negatives is a negative. But because the signs are different, they're going to be a negative. So for example 3. Well, what I like to do is let's just go ahead and focus on the sign. We have a negative times a negative, which we know is going to be a positive. So that's just going to be 5 times 7. Well, what's 5 times 7? That's 35. And B, negative 4 times 6. That's going to be, well, negative times a positive is going to be a negative. So then that's just 4 times 6. And what is 4 times 6? 4 times 6 is 24. And C, negative 6 divided by 12. Well, let's first do the division. 6 divided by 12. Those are both divisible by 6. So 6 divided by 6 is going to be 1. And 12 divided by 6 is going to be 2. But on the top, we had that negative. Okay? But since it was a negative over a positive, it's still going to end up just being a negative number. Okay, and these ones, for some reason, got cut off down here, so I'm going to go ahead and rewrite them up here. I will need to make a note of that for the next time I upload these notes. Sorry about that. Let's go ahead and white these out. All right, D. Part D. Negative 25 divided by negative 25. Okay, so another way of thinking it too is if you have a negative number divided by a negative number, it's also going to be a positive number. Okay, so what we have here is negative 25 divided by negative 5. So a negative divided by negative is going to be a positive, which means I'm just going to have 25 divided by 5. Well, 25 divided by 5 is going to be 5. Another way to think of it is 25, they're both divisible by 5. So we'll be left with 5 over 1, which is the same as 5. All right, let's take a look at E. First things first, we want to change these into mixed improper fractions first. Okay, so changing this into an improper fraction, I'm going to get, let's see. So when you do that, you're going to ignore the negative first. That's going to be 4 times 3, which is going to be 12. Okay, so you're not going to do 4 times negative 3. Sorry, you're not going to do 3 times negative 4. You ignore the negative first. 4 times 3 is 12, plus the 2 is going to be 14. 14 over 3, and then include the fact that it's a negative fraction. All right, so now we can say, since it's a negative times a negative, that's going to be positive. So we have 14 over 3 times 1 over 2. And then, let's see, can we simplify these? Well, 14 and 2 can both be divided by 2. 2 divided by 2 is 1. 14 divided by 2 is 7. So I'm left with 7 over 3 times 1 over 1, which is going to be 7 over 3. And the mixed number answer is going to be, well, 3 can go to 7 2 times, and that is left over. So now, when we're dividing using the number 0, you need to be careful. 0 is a little tricky. So we're going to say let n be any number except for 0. So n can be 1, 2, 3, 4, negative 7, 2.35, any number. So we have the two following options. 0 can be in the numerator, or 0 can be in the denominator. Their answers are going to be very different, so please be careful. If 0 is in the numerator, you can think of this as on, go on to the answer 0. And if you have n, but the denominator is 0, you think of this as no can do. Your answer is undefined. Okay? So if you have 0 in the denominator, your answer is called undefined. But if you have 0 in the numerator, your answer is 0. Let's take a look at these examples. 0 divided by 5. Well, that's the same as 0 over 5, which we know is going to be 0. Let's look at the next one. Negative 9 divided by 0. Well, we know that anything divided by 0 is undefined, regardless of what the number on the top is, even if it's a negative 9. So that's going to be undefined. Okay, and please notice I'm using the equal signs as I go along, just to let you know where my work is. So please make sure to do that in your own work when you upload your lecture notes. Make sure you're showing your work neatly and clearly, which is part of one of the student learning outcomes for this course, is that you can clearly express to me mathematical language. Awesome. Okay, next one. 6 minus 6 over 12. Well, first we need to do the subtraction before we do the division. So 6 minus 6 is 0 over 12. Oh, 0 over any number is going to be 0. Awesome. All right, next one for this page. Positive exponents. N to the a power means we will write out n times itself a number of times. All right, let's see what that actually means. Okay, so we have this number, negative 4 to the third power. Well, that means I'm going to write negative 4 times itself how many times? 3 times. Okay, so let's first focus on the 2 to the left, excuse me. Negative times negative is going to be positive. So then 4 times 4 is 16. And then we'll bring down that negative 14. Sorry, that negative 4. So then we have a positive times a negative. So my answer is going to be negative. But then what is 16 times 4? Let's do that on the side. So that's going to be 6 times 4, which is 24. 4 times 1 is 4, plus 2 is 6. So our answer is going to be negative 64. All right, let's take a look at B. Now, careful, you might be really tempted to think this is saying negative 4 to the third power. Well, what this is saying is negative 4 to the third power. This is saying take the opposite of whatever 4 to the third power is. Very different than this problem. Okay, the parentheses makes a huge difference in mathematical language. So this is going to be the opposite of what 4 to the third power is saying. We want 4 3 times. So 4 times 4 times 4. That's going to equal negative. Well, remember 4 times 4, that was 16 times 4. And then 16 times 4, remember it was 64. And we want the negative version of that. And there we go. Okay, so you might be tempted to say, but the answers turned out exactly the same. If you do this with a different exponent value, your answer will end up being different. For example, if you chose the exponent 2 or 4, your answer is going to end up being different. All right, let's look at C. Negative 1 to the 8th power. Ooh, that's interesting. So this is saying negative 1 times negative 1 times negative 1. Gosh, how many negative 1s are we going to have to write here? Running out of room. 1, 2, 3, 4, 5, 6, 7, 8. Whew. So then negative times negative is a positive. Times another negative is a positive. Times a... Oh my gosh, there's so many positives. You know what? There's a shortcut way to do this. Here's the shortcut. If you have a negative in parentheses raised to a power, if this power is even, your answer is going to be positive. If this answer is odd, your answer is going to be negative. Okay, so since this is an even, I know my answer is going to be a positive. So the question is, what is 1 times itself 8 times? That's just going to be 1. You can times 1 to itself 100 times, and it's still just going to be 1. All right, so remember that. It's a good thing to remember. Last page. Comparisons on the number line. So fill in the blanks with a less than or greater than to make a true statement. So is 5 greater than or less than 3? Well, 5 is greater than 3. So we're going to use that symbol. So remember, think of Pac-Man. He wants to eat the bigger item. So he's going to tilt towards 5. Go ahead and try filling the other ones by yourself. All right, 1 and 10. Which one's bigger? Well, let's look at the number line. Here's 0, there's negative 1, and there's negative 10. Which one is bigger? Well, remember, anything to the right on the number line is the larger number. So technically, negative 1 is the larger number. Because anything to the right is the larger numbers. Remember, if you have 1 and 5, 5 is the larger number. So 1 is the larger number. Oh, fractions. Fractions aren't always the greatest, but we can learn to work with fractions. So here's the number line again. And I'm going to do negative 1 because we know that these two fraction values are between 1 and 0. So first, let's focus on the negative 2/5. I'm going to split this into 5s. 1, 2, 3, 4, 5. Negative 2/5. Oops, sorry. So negative 2/5 is going to be 1, 2. So now, after I've done that, let's focus on the 3s. Let's split this into 3. 1, 2, 1, 2, 3. Oh, I realized I just split that wrong. Let me redo that real quick. Okay. Splitting the number line for 2/5 again. Sorry about that. I need to split it into fives. 1, 2, 3, 4. There we go, it's fives. 1, 2, 3, 4, 5. Awesome. So then we want 2 of them, so 1 2/5. And then let's put it into thirds. So 1, 2. Okay, so where's 1/3? 1/3 is going to be right here, negative 1/3. So which one's bigger? Well, it's going to be the negative 1/3 is greater. Another way we could do this problem, instead of looking at the number line, is we could make them have the same denominator. When we do that, we can just compare the numerators. So let's go ahead and give them the same denominator first. 5 and 3 are not the same. I want to make them, what's a common denominator for 5 and 3? 15. So I'm going to try and make them both have the denominator 15, which means I'll do the building up property for both of them. So that's going to be 6 over 15, and that's going to be 5 over 15. Aha, so which one is actually going to be the bigger? Remember, these are negative numbers, so 5 over 15 is to the more right, which is true. It's greater. Okay, so you could either do the number line version, comparing them on the number line, or you can compare them by making the same denominator. Last page. So Barry owns 220 shares of tech stock. At the highest point on a particular day, his stock was worth $26.03 per share. By the end of the day, it had dropped to $24.25 per share. What is the total change in value of Barry's 2020 shares? Okay. Well, first off, what's the change between 26.03 and 24.25? Let's check that out. What's the difference between these two? Okay, well, doing subtraction, I'm going to need to borrow from that 3, but I can't borrow from 0. So that's going to be a 9, and that'll be 5. And there we go, 13. So 5 and 13, that's going to be 8, I believe. Yep. And then 9 minus 2 is going to be 7. 5 minus 4 is going to be 1. And 2 minus 2 is going to be 0. So there is a $1.78 difference in stock. So we know there's a $1.78 difference. But that's not the total change. He wants to know the total change for all of his stocks combined. And that's just the change between one stock. So how do you find out the total? Well, each stock has a $1.78 difference, which means I need to check what 220 times 178 is going to be. Okay, so let's go ahead and multiply. 8 times 0 is going to be 0. 8 times 2 is 16. 8 times 2 again is 16, plus 1, 17. Let's add that 0 for the cycle. 7 times 0 is going to be 0. 7 times 1 is 14. 7 times 2 is 14, plus 1, 15. And another zeros for the next cycle. 1 times 0 is 0. 1 times 2 is 2. And 1 times 2 again is 2. So we'll go ahead and add those up. 0, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4. 4 plus 5 is 9. And last 2 plus 1 is 3. So how many decimal places do we choose to move over? Well, the total amount we see is just 2. So we're going to go 1, 2. So what is the total change in value? The total change